Hello everyone and welcome to Thinking with Mathematical Models 4.1. Our learning target today is we'll draw a line of best fit, otherwise known as a mathematical model, to make predictions. Our ACES questions for 4.1 are just going to be numbers 1 through 3. So in 4.1, this says Vitruvian man relating body measurements, but what we're getting into is what's called a scatter plot. And we take data points and we put them on a graph, and they don't line up in a perfect line. So that's why we then draw a line of best fit through those data points to best represent that. Now you're going to have some data points that are what are known as outliers that don't really fit the model, that aren't close to the line at all, but we would try to draw the line so that it's near as many points from our table as possible. So for this particular problem, it says more than 2,000 years ago, a Roman architect and writer named Vitruvius found patterns by relating two body measurements. He claimed a person's arm span, that's if you put your arms out parallel to the ground from fingertip to fingertip, that the arm span is equal to his or her height. So that when you stick your arms out from fingertip to fingertip, that's the same distance as it is from your head to your toes. There's more background information here if you want to go to this link. I'm going to get to the right spot here. It'll take you to this website, and there's a lot more information here about arm span versus height if that's something you'd like to research a little bit further. But as we get into our problem here, we're going to do parts A, B, and D. We'll go ahead and skip C. And it gives us a table of data here, and it asks us to plot it or graph it over here on your graph, and I've already done that, represented that here. And so as you can see, it's not a perfectly straight line. This is what is known as our scatter plot. So I want you to go ahead and do that as well. Take the data that you have here and plot it out on a graph. And then it asks you, do you think the scatter plot supports the claim that arm span and height are about equal for most people? And if each student in the class had arm span S equal to height H, what equation would relate to two variables? Well, span equals height. We could change our letters and make it y equals x if we wanted to. So it says graph the equation on the scatter plot. Well, what it's asking you to do there then is to, if it says that S equals H, well, where this is 52, this is going to be 52. So our line would match and just go through corner of each of those grids. And this would be our line of best fit if we use this equation of span equals height. As you'll notice, if you can go anywhere and see that the measurements are the same, 62 here, 62 there, anywhere along the graph. It asks which data points, if any, does your line pass through? So which ones does it directly pass through that are already on the graph? And explain how arm span and height are related to those points. And choose several data points that are not on your line. Explain how arm span and height are related in each case. Describe the relationship shown on the graph. Okay, so are they taller or is their arm span longer? Give some relationships like that. Part B gives us a little bit more history. Tells the tallest person in recorded history was Robert Pershing Wadlow. At age 22, he was 8 feet 11.1 inches. That's tall. And his arm span was even greater, 9 feet 5.75 inches. So it asks us, where would we plot the point for Robert Wadlow, and would the point be on, above, or below the line you drew? Now that line's going to be like clear out here somewhere, or that point is going to be clear out here somewhere, so you'd have to have your line extended. Do you think it would be above, below, or on that line? And does the data point for Robert Wadlow support the claim that arm span and height are roughly equal? Finally, in D, talks about Tyrannosaurus rex. He's 20 feet tall with an arm span of 10 feet. Do you think his data point fits in the arm span equals height? And if you plot the data, would it be on, above, or below the line? Finally, shortest person here, a little more information for you. You can pause the video and read that. And a reminder that our ACES questions are 1 through 3. Hope that's helpful. Look forward to answering your questions in class.